Okay. So today we are going to discuss about motion of center of mass. Now, why we are studying a motion of center of mass? Because see, if I draw here object, okay. Now, this ball is moving, right? Suppose this is a ball, center is here, and this is moving with velocity v. Let's name it as center of mass, PCM. Okay, and this particle, let's take particle P. This is also velocity. It is also moving. This ball is moving this direction. So velocity for particle P, where it will be? Can you guess the direction? Right or left?
Right.
Right? Actually,
Left.
no. See, this ball is moving this direction, but velocity of this particle Vp, this velocity is moving this way. This ball is moving in this direction and rolling like that. Is moving, movement is in this direction, but it is actually ball. How ball
Oh yeah,
moves,
if you're talking slow movement, yes, it's moving like that.
right? It ball does
Yeah.
not like
Makes
drag.
sense if you imagine it.
Yeah, it rolls. It rolls like that.
Yeah.
So in general, if I say each particle have different velocity, right? I can say each particle have different velocity. They won't be fixed here, but overall velocity will be in this direction, which is VCM. So I can say one more thing. At each point there will be two velocities. One in the direction of motion, and one which is making it to roll. One which is making it to roll. There is also a velocity, right? So one which is making it to roll, that is also velocity, and direction of motion, which is BCM, with respect to center of mass. That is what we are going to discuss all this thing here. Okay. So for motion, what we need? We need velocity, then acceleration. These both are what? Linear. Linear velocity, linear acceleration. And what was that R vector? Directional vector? Do you remember? What was our directional vector? You forgot. Yesterday, like day before yesterday only we did. Anyone? Varun, Devanshika, Ritvik, Sai. Do you remember this formula? Is my voice breaking? Is it clear?
Clear, sir.
Okay. So don't you remember the formula? Summation of?
MIXI.
Oh, MIXI by M.
No. That is
So
for
in
X.
this V1, it's V1.
RI.
Nice, RI.
Okay.
Right.
R.
Yeah.
M.
For positional vector. Okay, don't forget whatever we got the formulas last class. Now from this one, I can take this side M on other side, M R vector, which is summation of Mi Ri. What is summation of Mi Ri? M1, M2, M3, R1, R2, R3, correct? So
Yeah.
M1, R1, plus
plus
M2
R2
R2
factor plus so on M.
N
Yeah.
MnRn. Yeah, N value.
So here, this one we can write as differentiation of, if I want to change into velocity, this one, what's velocity? dv by,
dt.
that is acceleration, dv by dt, that is acceleration.
Yeah.
If I want v, ds by dt. ds is what? Displacement or position, or dx by dt,
Yeah.
whatever position we have. Right? That's what you studied in kinematics.
Yes, sir. Pretty much.
Yeah. So M. See, whenever you didn't understand anything, whenever you are not able to get this concept, you can tell me in the straight. So what I'm doing, all this R, I'm differentiating with respect to T, because I want to introduce velocity. I'm differentiating. I cannot do on the left side and I will just left them alone, right side. No, I cannot do that. So whatever I'm doing, I should do both sides. So dr by dt, which is equals to m1 dr1 by dt plus, similar way, what will be next? M2,
By dt.
yeah, and so on till mn.
Mn drn by dt.
Don't take this as a multiplication, okay? Like this is just suffix, chota chota.
Yeah. The base.
Yeah, dt. So dr by dt, which is velocity, mv equals to m1 v1 plus m2 v2
V2
plus,
Mn Vn.
exactly. So let's go back to the summation form. We started here. Let's go back there. MV. What will write this side? Yes, Devanshika. Summation form. What will write here? You there, Devanshika? Yes, anyone know that? Any of you? We are just going back how we started this form. Summation form.
summation of mi vi by n.
Exactly. Summation of mi vi. Now v equals to summation of mi
Mi Vi by
Vi
N.
by
N. M.
M
M.
this was velocity. Now, how to find acceleration? Acceleration was dv by
v by
dt.
dt.
Now, this equation will differentiate with respect to t.
t. Yes, sir.
Come on, try this. Sainitya, are you there, right? Oh, yes, sir. Okay. What happened to Devanshika?
Sir,
Oh, you there?
yes, sir.
Aren't you feeling sleepy, right?
No, sir. Actually, I went to bring my book, sir.
Okay, okay. Yeah, no problem. No, your voice sounds like you're feeling so sleepy, tired of the day.
No, sir.
Fine. Okay, let's differentiate this equation. Okay, who will tell me? M. Differentiate this equation with respect to t. Who will tell me? Come on, come on, fast, fast, fast. Varun, tell me.
This also like MA is equals to M1 plus M2.
No, in form of differentiate this
Differentiation.
equation. Yeah, with respect to t.
Like
So dv by dt equals to, see, whatever we did this case, same thing we are doing here. We started here to get this velocity. Now we are doing for velocity to get acceleration.
same MV1 by dt.
Yeah.
dv1 by
M1 dv1 by
dv1 by dt
dt plus
plus M2 dv2 by
dt plus so on.
so on mn
Mn
dn dvn by dt.
dt. So dv by dt is acceleration.
Acceleration ma
Ma, which is
equals to
M1
a1
A1 plus
m2 a2 plus
M2
m3 a3
A2 plus
so on mn
Mn
an.
An. Okay. Now all these are mass into acceleration. So what is it?
Force.
Force. This is,
F.
my F became so big. Force equals to F1.
F1 plus F2 so on Fn.
Yes. F and. But now this force is external force.
Yes, sir.
Now each term, what was F1? See, just let's take one term. F1. What is F1?
M1 A1
M1 A1. Now what was A1? V
A1
by
is
V.
V by
V1 by T.
T. Yes, sir.
Right. What was V? R1.
R1 by T.
Right. So we can write this one as, let's conclude this. F1 is as this vector sum of all forces on the which particle? First particle.
First particle.
Similar way we can write. So no need to just write again and again. So F1 is vector sum of all the particles, sorry, all the forces on first particle. Clear? Clear for everyone? Or you want me to repeat
Yes,
this
sir.
again?
Yes, sir.
Sainitya, clear? If you cannot speak, at least like if you have doubt, you can raise your hand. Okay. Right now, still we are discussing what? Acceleration and velocity. Linear, right?
Yes.
Still we are going to discuss about linear momentum. Now, what is momentum?
Mass into velocity.
Exactly. Total mass into
So
velocity.
Velocity.
Okay, this is not cross product. I'm just multiplying it. As I didn't mention here, vector, so you can understand, right?
Yeah.
Okay. So linear momentum. So we can write like it's a total mass into velocity, total mass of the system. Sorry. Yeah, total mass of system, velocity. So let's make a definition, or let's write some statement. Total momentum of a system of particles is equals to product of total mass of system and velocity, or multiplied by velocity. Of its center of mass. So what is linear momentum? Or momentum is product of mass and velocity, or mass of a system. Now, if it is m1 v1, sorry, m and v, still we can get this same way because it says system of particles, right? Similar way we can write this. We're not deriving same way again and again. So just tell me directly. It will be for P1, it will be for P2, it will be for P3. So what will be for P1?
M1
This term, right? This will be for momentum. I can use this as a momentum. Now velocity of center of mass. So let's take this as a VCM. So momentum equals to P1 plus,
plus P2 plus
yes, plus,
P1 Pn.
yeah, Pn. So P1 will be
M1 V1.
exactly. P2 will be
V2.
M2
M2 V2.
exactly.
Pn is M1 Vn.
MV, MN, V1, N.
Mn
VN.
Pn. That is P. So in summation form,
Mi Vi by
MIVI. Now for center of mass, velocity VCM will be, what was VCM? MIVI by
Vi
M.
by Ms.
Summation of VI by
M.
M. So M VCM equals to summation of MI VI which is equals to momentum of center of mass. Same thing I'm saying. Okay. Second law. Okay, then let me ask someone. Yes, Devanshika. What is Newton's second law? You remember? No, you don't? Okay. Ritvik, what's Newton's second law?
Sir,
Yeah, yeah.
so Devanshika.
Yeah, I know.
So the rate of change of momentum of a body is directly proportional to the external force.
Okay, is directly proportional to the external force in the direction of force.
Force.
Yeah. Okay. So here we are going to differentiate this one with respect to t. So dp by dt, which is equals to, yes, Ritvik, what will get here? This side? M
MVCM.
Okay, we CM D. We are differentiating both sides.
Yeah.
Whenever we differentiate one side, we should differentiate other side also. dV by
By
DT.
We CM only. I'm not writing here. It's understandable now. Because whatever we discuss, it will be for center of mass until and unless they ask some particular. So dV by dt, what was dV by dt? Where is it? What was dV by dt?
A.
J.
Yes, acceleration. See, this is all are related. Are you getting bored of this?
No, sir.
No, if you're getting bored, just tell me.
No, sir.
I'll directly start some numerical.
No, sir. Fine.
See, I won't feel bad. Okay, sir, I'm getting a little bit bored. Shall we do some numerical? Yeah, fine with me. Okay, don't feel like shy to say anything. Okay, dp by dt equals to ma. Ma equals to external force. Still, we are just moving round and round of that thing. Okay. So can someone tell me what is law of conservation of momentum? Do you remember? Varun?
So total momentum of two objects before and after collision
Yeah.
is equal to
Before and after
momentum
will
of
be
collision.
equal.
Yes.
Yeah. That means some of them it should be 0.
Yes.
So if F external is equals to 0, that means dp by dt is equals to 0. Therefore, P is constant. Clear?
Yes, sir.
Sure.
Why not Striker not yet joined?
No ideas.
Okay. Now first, before doing all those things, let's little bit small revision of vectors. Not everything.
So Srikar says he's having internet problems. So.
Oh, is it?
Yeah.
Okay. No wrong. Anyhow, it is recording. You can watch it later.
Yeah. Okay, so let's continue.
Okay. So vector product of vector. Vector product of vector. Now, as we saw, A dot B, as we know that this is scalar product or
Vector product.
Vector product.
yeah, scalar. No, it is dot product. Yeah,
Dot product.
Yeah, dot product. Yeah. A
scalar
dot
product.
B is equal to, yeah, you know the formula. Length of A dot and
Hmm.
length of B dot cos theta. Right?
Yes. We're not going to do all those things. Just small, like let
Yes, sir.
because we already discussed that in first chapter itself. Okay. So A dot B, which is scalar or dot product. So resultant of dot product is not scalar. Sorry, not vector.
Not vector.
It's not a
Yeah.
vector. It's just scalar, but it shows what? Projection. It is just for projection. So for a note, you can write it just shows projection. So properties you know, right? Commutative property, A cross B. Cross product. Okay, no problem. Let's revise the cross product also. Because we will use every moment in this chapter. That's why we need to revise. You all are math student, right? So you should love this vector. If you don't like, still you should start learning, loving this chapter, vector. It's most important. Take an angle at theta. So cross product of A and B will be cross B. So magnitude of C will be AB sine theta, right? Yeah.
Yeah.
So theta is angle between
A vector and B vector.
Exactly. A and B. So now direction of C will be
Same.
perpendicular to plane of A and B. B vector. So how to find this? By the right hand rule, right? Can I draw that? B, this is A, this is C. So if we curl our finger on this way, so our thumb will show this direction. Thumb, fingers are here. That means direction of C here. See how we are holding like this. If I erase this, it will be visible properly. Okay. So we are holding this finger on this way. Our fingers are here. So thumb will show the direction of C or resultant. Right hand. How we are holding like in 10th standard we were doing, right? Like Fleming's right hand rule, Fleming's left hand rule. Similar way. It is similar to that. You remember Fleming's right hand and left hand rule? No?
No, that's
From what? Acha. Okay. But condition is that, see, rotation means our fingers are we are curling this way. That means we will measure angle from this direction. Let me write that in a note so that if you see later, you'll be note able to understand. Like rotation should be taken on this side, right? So there is what 180 should be taken through smaller angle. If you're curling this way, so we should not take this direction. It will be bigger one. We should take lesser than smaller angle. Okay. Here also possible, right? We can take direction this way. We can take angle this direction also. Both side we can do because it's 3-dimensional figure. Understood this one? We should take smaller angle. Yeah. That's right. Less than 180. Are you getting this? Yes. No. Don't know. Is my voice not reaching your ear? What is it, man? Acha. So what happened to this 3? It's reaching to sign. What about this 3?
Sir,
Acha. Okay. So properties of vector product. It is not commutative. Cross product. Okay. Vector cross product. What is commutative property? Varun? Ritvik?
A plus B is equal to B plus C.
Yeah. Not plus or here cross.
Into S cross. Sir.
Here
A
we'll
into
take
B is equal
cross.
to B into A.
Yeah. But here it is not correct.
Cross.
It is because it is not commutative. A cross B vector, which is not equals to B cross,
A.
but it is equals to opposite of this one. A cross B is equals to minus of,
S of B cross.
yes,
Because it-
minus B is the reflection of B. Minus B is the reflection of B. So no change on reflection. Suppose I'm taking A cross B, which can be minus of A cross minus of B. Similar way, if you want to write for distributive, what we'll do? What is distributive property?
A dot of B plus C is equals to A dot B plus B A dot C.
Yes. Now I want with cross product. So what you will write?
Plus C is equals to AC. AB cross AC.
Yes. No, not A B. A cross B
A cross
plus
B,
A cross
C cross
C.
C.
A plus B across C.
No. First we will do with this one to this one plus this cross this. Or distributed. So A cross
B
B,
plus C.
yes, plus A cross, that is distributed.
Yeah.
Okay. There is a reason behind doing all those things. And one more thing, because we won't, now we will start vector addition here also. IJK. Whenever we are doing numerical, it will be in form of IJK. So let's see that. You know determinant, how to find determinant? Matrices. Have you studied that or not yet?
Sir, determine
Yes, I've studied.
Right. Okay. So for this vector I cross I will be 0.
0.
These are caps, okay. I cross j will be what? We don't know.
1.
I cross k, that also we don't know. Let's see. Another one. J cross I, we don't know. J cross j equals to 0.
0.
J cross k. Let's find out this two remaining. See how to remember. I'll tell you a small trick to remember because these are so many values, right? 3, 3, 3, and one more 3. K cross I, K cross j, K cross k.
0.
Now, how to remember this? If you know, then good. If not, then learn it. Now, we are crossing this one. I cross j. So, what is left? Plus
K.
k.
Plus K.
Now, j cross k. What is left?
I.
Plus
Minus plus I.
plus I. Reverse of that is minus I. K cross I,
Minus j.
Minus J.
no, plus j. K cross I. I cross k is minus j.
Okay.
Right. Now, let's fill this. Opposite of that is minus. Minus of those answers. Minus of those people. Okay, I cross j, it will be plus
Plus K. Plus K.
jk plus I, and this one kj
Minus I.
no kj plus j.
Minus I.
No,
Minus
plus
I
j.
na sir.
K, oh sorry, yeah, correct.
Minus I.
Yeah, minus I only.
Sorry, yeah, minus. Ki is plus j, right? Yes.
Yeah.
Yes, sir.
Ki is plus j. Okay. So kj minus I.
Minus I.
Yeah.
Then ji,
Minus k.
Minus K.
and ik.
Minus J.
Plus.
Minus J.
Ki
Yeah, minus
is
j.
plus, and it is minus j.
Yeah.
So if you remember this three, it's done. So let's do this. Shall I scroll down, or you all are doing something here? Shall I scroll?
Yes, sir.
Okay. So A is given as AXI cap plus AY J cap plus AZ K cap. Now B is given as,
BX plus BY.
yes, similar way. Now what you have to find out?
A.
Yes, A cross B. So whole term here, cross, whole term there. Now let's write this AX I cap plus AY J cap plus AZ K cap. Same BX I cap plus BY J cap plus BZ K cap. Now what we'll do, we'll just multiply this term here to there and there. Similar way, multiply here, here, and here. This one.
Plus
this one,
that,
and
that
this
is
one.
it.
Okay, so this will be so long. Instead of that, we have one thing that is matrices.
Matrix.
Yeah, matrices help us to reduce our hard work. So simply we can write this one. Or shall I show you this how we are multiplying? Or you know, just multiply this to this, then again this term to this term, this term to this term. So I and I, whatever we get, 0. I and j will get plus k. Then I and k, what will get? Minus j.
Minus j.
Right. Similar way we will do. Like there will be 3-4 steps will follow. Instead of that, we'll follow matrices. So write all the terms in matrix. So if this is I,
J.
j term, k term. Okay. So first, let's take A row, then this as a B row. AX,
AY,
Y,
AZ.
AZ. X, BY,
Then we can find determinant.
determinant. Yes.
I into
Okay. This term cross here for I first. So let me choose another color. For second,
AX into BZ, sir, and BX into AZ.
exactly. For third,
X into
AX, BY,
BY.
BX, and AY.
exactly. Okay. Now can you try this? Do everyone know this? How to do?
Yes, sir.
What about Devanshika?
Yes, sir.
Okay. Sai, you know how to solve this? If not, raise your hand. I will show you how. Okay then. I'll just directly write this answer here. So I, what you will get? X, Y is 0. BZ, BY, AZ
Plus minus
minus of J term. Second term will be minus.
minus. AX, BZ,
Minus AZ, BX plus K term.
AX, BY, BX, AY.
That's it. So we got IJK. Actually, let's write IJK at the back. I cap, J cap. This is the cross product of A and B. Done?
Yes, sir.
Devanshika?
Yes, sir.
Okay. Ritvik?
Yep, done, sir.
Okay. What about Sai? She's okay. No, whatever we studied till now, it was linear. Let's go with angular. So we are going in rotational part. Till now we saw system of particle, linear motion, and matrices or vectors. Cross product, right? Now we'll see rotational part or circular part. So first thing we started as velocity. So let's talk about velocity. Angular velocity. Okay, by the way, what was velocity?
Displacement by time.
Yes, displacement by time or change in position with respect to time.
Rate of change of displacement with respect to time.
Exactly. Right. So in angular, it will be similar, just angular displacement. Angular displacement per unit time. Linear velocity was displacement by time or change in position with time. That was linear. Now some more thing we studied in linear velocity. What was that? Velocity, then average velocity. Do you remember average velocity? Instantaneous velocity. What is instantaneous velocity?
Non-uniform velocities.
No, not like that. Name itself suggests. Name. What is name? Instant. Instantaneous. So velocity at particular instant.
Specific
That
point
is,
of time.
yeah, at some particular time. That is instantaneous.
Instantaneous velocity.
And average velocity will be, what is average velocity? Okay, say something like name itself.
Displacement over a time.
Total displacement by
Displacement over
total time.
Yes, sir. Total time.
Average. We are taking average of that. Right? How we find average generally? We divide total number of marks divided by what? Subject.
Yeah, total subject.
Total subjects and total marks. That way we find average. And whatever we are finding, that is percentage average. Okay. So here, that's what we are going to not show. See instantaneous angular velocity and average angular velocity. That's what we are going to discuss. So if we have time, do you have any class after this?
No, sir, none.
You want me to stop or shall I continue? Or we can start next class also. Your wish.
Your wish, sir.
See, don't give me option.
Anything is fine, sir.
Okay. Okay, they are saying, okay, enough, please. Okay. Yeah, fine. So let's wind up today. Then we'll continue with all the angulars thing. Rotational motion. We'll go with rotational motion all. So any doubt in today's class?
No, sir.
No, sir.
Are you sure of it?
Yes, sir.
Okay then. Okay. So I'm not stopping. I'm just stopping this.